I'm back with another PERT math review. This time the review is a little bit more Algebra 1 based. You'll notice that I have 20 questions here. I'm going to split this up into two parts. So this is part 1, which is going to be questions 1 through 11. And then for the next, but that's the first column. Then for the next video, it'll be numbers 12 through 20. So let's get started with number 1. Just like my other video, I'm going to read the question, I'm going to give you the answer, then I'm going to show you how to do it. That gives you the chance to do it on your own and check your answer. If it's right, you can move on to the next problem. And if it's not right, you'll see the steps on how you actually should have done it. So let's look at number 1. Number 1 says solve the equation negative 3x minus 2 in parentheses x minus 6 equals 4 minus 5 plus 3x. The correct answer for this would be 13 halves. So x equals 13 over 2. Let's see how we got that. I'm going to start by just writing the equation negative 3x minus 2 in parentheses x minus 6 equals 4 minus in parentheses 5 plus 3x. The first thing that I'm going to do is clean up both sides. And what that means is I'm going to look just at the left side and see if there's anything I can distribute or anything I can combine. And then I'm going to do the same on the right side. So on the left side, I realize that I have that negative 2 that I can share with this group of parentheses. The negative 3x will stay exactly the same, but negative 2 times x is negative 2x, and negative 2 times negative 6 is positive 12. Then I notice that I have like terms I can combine. So because these both have an x value, negative 3x and negative 2x, I'm going to combine those. The x will stay the same, but negative 3 minus 2 is negative 5. And then the plus 12 stays exactly the same. I can't combine these terms because one has an x and one doesn't. On the other side, I'm going to do the same thing. The 4 is going to stay the same, but I'm going to distribute the negative to the 5 and the 3x. Essentially, what this means is that both terms are positive, but they're going to become negative, minus 5 and minus 3x. Then I'm going to do the same thing and combine like terms. 4 minus 5, they don't have x terms like the negative 3x. So I'm simply going to do 4 minus 5 is negative 1, and then the minus 3x stays the same. At this point, I'm going to be using inverse operations to bring my x values to one side and my numbers to the other. It doesn't matter which side you bring the x values to, as long as the x's are on one side and the numbers are on the other. So I'm going to start by adding 3x to both sides. And when I do this, my x's on the right side cancel out. Negative 5 plus 3 is negative 2, and the x stays the same. So now I have negative 2x plus 12 equals negative 1. From here, I'm going to subtract 12 on both sides. The negative 2x stays exactly the same. The x's will cancel out, and now I have negative 1 minus 12, which is negative 13. My last step is to divide both sides by negative 2. Make sure you divide by a negative 2 and not just a positive 2. We only want the x to be left on the left side. My negative 2's cancel and I get x equals. On the left side, on the right side, I can't simplify 13 over 2. I'm just going to get a decimal. So I'm going to leave it as an improper fraction, but because both my top and bottom are negative, my fraction becomes positive. So my answer is 13 halves. Number 2 says x minus 3 over 2x plus 5 equals 3 over 5. For this one, our answer is going to be x equals negative 30. So for number 2, I'm going to set these equal to each other as they're already written. 2x plus 5 equals 3 over 5. I'm going to use the technique of cross multiplying. Some of you might refer to this as the butterfly method, but basically what I do is I take the upper left times the bottom right. Then I'm going to do the bottom left times the upper right. So when I multiply the red together, I'm going to have 5 times x minus 3. And that's going to be equal to the blue side, which is 3 times 2x plus 5. It's really important to think of the x minus 3 as one group and the 2x plus 5 as one group. So really what you're saying is 5 times x minus 3 as a group, and then 3 times 2x plus 5 as a group. The reason this is so important is because we're going to have to distribute. So the 5 times x becomes 5x, and the 5 times negative 3 becomes negative 15. On the right-hand side, I'm going to distribute the 3, and it's going to become 3 times 2x is 6x, and 3 times 5 is 15. Oh, I'm actually going to make that white. So from here, I'm going to draw my line down the middle. And again, my goal is to get the x values on one side and the numbers on the other. I'm going to subtract 6x from both sides, which will give me negative 1x minus 15 equals, my 6x's cancel, 15. Then I'm going to add 15 to both sides. And I'm going to get negative x equals 30. From here, because negative x equals 30, that would mean positive x equals negative 30. Or you can say I'm going to divide both sides by negative 1, which would give us x equals negative 30. Let's look at number 3. Number 3 says Joe earns $250 for selling $5,600 worth of merchandise. What was his commission rate? Well, that's going to be a percentage. That's like saying $280 is, which is equals, what percent, so x, because that's what you're solving for, what percent of 5,600? Of means multiply, and 5,600 is the total. So the way that we would normally see this is 280 equals 5,600x. In order to solve this, we're going to divide both sides by 5,600. So you can type this into your calculator and you'll get x equals 0.05 or 5%. Or you could also look at this as a fraction and you could be simplifying it that way as well. But eventually you're going to get to 0.05 or 5%, which is your answer for number 3. Let's look at number 4. In number 4, it says that Mike borrowed $2,500 at 7% interest for 5 years. Find the amount of money Mike will have to pay back. Well, the correct answer would be $3,375. If he borrows $2,500, that means that he's definitely going to have to pay back that amount, but he's also going to have to pay back 7%, which is 0.07 of $2,500. When you type that into your calculator, you'll get 0.07 times 2,500 is $175. So not only is he paying back the $2,500, but he's also going to pay back $175. And because he's doing this for 5 years, it's not just $175, it's 175 times 5, which is 875. So the original amount of $2,500, the interest amount of $875, and when we add that together, we get $3,375. Find 3 consecutive odd integers whose sum is 93. Those 3 integers are going to be 29, 31, and 33. To set this up, first off, we need 3 consecutive odd integers. Well, consecutive means one right after the other, like 1, 2, 3, 4, and 5. But if you're looking for consecutive odd integers, that would be 1, 3, and 5. Well, we know that our first letter, we don't know what our first number is, but we're going to represent that with the letter X. And in order to get to the next consecutive odd number, we're going to have to see how we go from 1 to 3, we add 2. Well, to get to the next number, we're going to take X and add 2. So our second number is going to be X plus 2. Notice from 1 to 4, we would have to add 4 to get to the next consecutive odd number. Well, I'm going to do X plus 4, and I'm going to get X plus 4 as my third digit. So my 3 numbers are X, X plus 2, and X plus 4. In order to make sure that the sum equals 93, we're going to add all of these together and set it equal to 93. I'm going to solve for x, and to do that, I'm going to combine all of my x terms. So x plus x equals 3x, and then 2 plus 4 equals 6. Now I'm going to solve for x. I'm going to subtract both sides by 6, and I'll get 3x equals 87. And when I divide both sides by 3, I'm going to get x equals 29. That's going to be my first answer. In order to get my other solutions, I have x equals 29, x plus 2 equals 31, and x plus 4 equals 33. Those are my three answers. In number 6, we're going to be solving a literal equation. Solve for L. P equals 2L plus 2W. That means we're going to use our inverse operations, but our answer is going to still have letters in it. And there's two different ways that you can write the answer: P minus 2W over 2, or P over 2 minus W. Well, let's see how you would solve it. P equals 2L plus 2W. We want to solve for L, so the L won't move, but everything else will. When you're using inverse operations, you're going to start with addition and subtraction. So we're going to move the entire term 2W. Because it's positive 2W, we're going to subtract 2W. What that means is on the left-hand side, we have P minus 2W equals 2L. My 2W's on the right-hand side will cancel out. My last step, in order to keep the L by itself, is to divide both sides by 2. So you get L equals P minus 2W over 2. To be honest, this does give you this answer as a solution, but really the best thing to do is to simplify it further. And what you would do is you would separate this into P over 2 minus 2W over 2 equals L. The reason this is helpful is you'll see that your 2's will cancel out and you'll be left with P over 2 minus W equals L. That would be most likely the solution that you're going to see on your exam. Number 7. In number 7, they ask us to solve the inequality and also graph it on a number line. So for number 7, our solution is going to be x is less than negative 12. And on a number line, you're going to have an open circle at negative 12, and you'll be shading everything to the left. So in order to solve this, we're going to do 4 times 2x plus 5 is less than 6x minus 4. Solving inequalities are basically the same as solving solutions. The difference is, number 1, you're going to get a lot more solutions for an inequality. And number 2, when you multiply or divide by a negative, you need to flip your inequality symbol. The first thing I'm going to do is simplify both sides. The 6x minus 4 is good, but on the left-hand side, it looks like I can't do anything inside the parentheses, so I'm going to distribute. 4 times 2x is 8x. 4 times 5 is 20. From here, even though I have an inequality symbol, I'm still going to draw that wall to remind myself I have a left side and a right side. With inequalities, it's really important to always bring the inequality to the left side. So I'm going to, or the variable to the left side. So I'm going to subtract 6x from both sides. That leaves me with 2x plus 20 is less than negative 4. Then I'll subtract 20 from both sides, and I'll get 2x is less than negative 24. My last step will be to divide both sides by 2, and I'll get x is less than negative 12. When you're graphing on a number line, remember that open circles are for less than or greater than, closed circles are for less than or equal to, greater than or equal to. Then you're going to shade whatever side your inequality is pointing to. So in this case, it's pointing to the left, so we shade to the left. Let's do number 8. Number 8 asks us to evaluate the expression 5x over x squared plus 2 when x equals negative 3. Now for number 8, the correct solution is going to be negative 15 over 11. In order to get that solution, I'm going to first write my equation 5x, or my expression 5x over x squared plus 2. I'm going to take out my variable and I'm going to replace it with -3. So my new numerator will be 5 times -3. And I put it in parentheses, not only to separate it from the number 5, so it's not 5 minus 3, but I also want to show multiplication. So this would say 5 times -3. On the bottom, I'm going to do -3 squared plus 2. So every time I saw that variable of x, I took it out and replaced it with a number. When I simplify, the top is -15, and the bottom would be -3 squared is 9 plus 2, which means my answer is -15 over 11. There's no way to simplify this since 11 is a prime number, and we cannot divide 15 divided by 11. Number 9. Number 9 asks us to simplify, and when we do simplify, we are going to get an answer of 8x to the 5th, y to the 8th. The work for this one, well, let's start by writing 2xy cubed is in parentheses raised to the power of 3 over x to the -2y. The first thing I'm going to do is solve my power to a power, which is my numerator. So inside the parentheses is going to be raised to another power, so we multiply. I'm going to bring that 3 to the 2, so that becomes 2 cubed. I'm going to bring that 3 to the x, and since it already has an exponent of 1, I'm going to do 1 times 3 is 3. Then I'm going to distribute that 3 to the other exponent of 3. 3 times 3 is 9. On the bottom, I still just have x minus 2y. I'm not distributing that exponent to the denominator because the parentheses are only around the top. They're only around the numerator. From here, I'm going to be dividing. And when you divide, you subtract your exponents. Well, 2 to the 3rd, 2 times 2 is 4 times 2 is 8. And 8 divided by 1 would just stay 8. In my next one, I have x to the 3rd and x to the -2. Well, 3 minus -2 actually becomes plus. So that's 3 plus 2, which is 5. So that's x to the 5th. I'm going to do the same thing for y. Even though you don't see it, the bottom y has an exponent of 1. 9 minus 1 equals 8. So it's y to the 8th. That's our answer. And our last one, number 10, actually, I'm sorry, I'm going to go to 11. So we're going to do 2 more. Number 10 asks us to do scientific notation. So our original number is 0.12345 zeros, 5432. So when you're writing the answer to this, the answer is going to look like 5.432 times 10 to the -6. When you have a very, very small decimal, your scientific notation will always be a negative exponent. And when you have a very large number, you're always going to have a positive exponent. The first thing you want to do is ignore all of these zeros and go to the first non-zero number, working from left to right, which is the number 5. Then I'm going to put my decimal point and I'm going to put the rest of the numbers, 4, 3, 2. Keep in mind too, if there's any zeros in between these numbers, that's fine, but you just want to make sure that you include all of your non-zero numbers. So I ignored the first couple of all of these zeros from here to here, and then I stopped at 5, which is my first non-zero digit, put the decimal point after that, and wrote everything else. Then I'm just going to write times 10, because that represents scientific notation, and I'm going to see how many times I need to move my decimal point. So it was over here. I'm going to move it over here. So that's 1, 2, 3, 4, 5, 6. And because it's a very, very small decimal, it's going to be -6. If this was a very large number, like 5 million, 5 billion, 5 trillion, that exponent would be positive. So this would be our correct answer right here. And then number 11 asks us to simplify. So we have 3x squared minus 5x plus 6. And from that, we're subtracting x squared plus 5x minus 1. The correct answer for this one is going to be 2x squared. I'm just going to write this. Let me put it over here like I always do. So 2x squared minus 10x plus 7. So let's simplify this. This is called subtracting polynomials. Remember, we're going to combine like terms. So we're looking for things that look the same. Before we start combining, we need to distribute this negative to everything in the second group of parentheses. So the 3x squared stays the same, minus 5x stays the same, and plus 6 stays the same. We're going to distribute that negative, so it's minus x squared, minus 5x, and plus 1. From here, we're going to look for terms that are the same. So we have an x squared term and an x squared term. We're going to combine our coefficients. So 3 minus 1 is 2, and the x squared stays the same. Those are done. Then we're going to move over to our x terms. Negative 5 minus 5 would be negative 10, and the x stays the same. Then we move on to our numbers. Positive 6 and positive 1 would give us an answer of positive 7. And there's our solution. You are all set for the first half of this placement test for the math PERT. I'm going to do the second half in another video, so look out for that one. Good luck.